Hello, good day everyone. My name is Dr. Kingsley. Welcome to my class today. My class today is on chemical equilibrium. When is a chemical reaction said to be in equilibrium? A chemical reaction is said to be in equilibrium when the rate of the forward reaction is equal to the rate of the backward reaction. And we understand that chemical equilibrium is not static equilibrium. It is a dynamic equilibrium because reactants are converted to products while the products are converted to reactants at the same rate. Now let us consider a reaction of this nature. A, a reactant A plus a reactant B giving us a product which is C and D. The reactants are A and B. The stoichiometric coefficient of the reactant A is small a, while the stoichiometric coefficient of the reactant B is small b. And this reaction produces products which are C and D, having stoichiometric coefficient of C and what? And small d. Now, if we consider this reaction, we can actually derive the law of mass action for this reaction. The law of chemical equilibrium is known as the law of mass action. Now, what is the law of mass action? The law of mass action states that the rate of a chemical reaction is directly proportional to the algebraic product of the concentration of the reactants, all raised to the product of their stoichiometric coefficient. I will come again. The law of mass action states that the rate of a chemical reaction is directly proportional to the algebraic product of the concentration of the reactants, all raised to the power of their stoichiometric coefficient. Now, if we understand this, we are having the reactants for the forward reaction. The reactants are A and B for the forward reaction. Then what is the law of mass action saying for the forward reaction? Now, for the forward reaction, the law of mass action is saying that the rate for the forward reaction will be directly proportional to the algebraic product of the concentration of A and B. So, rate for forward reaction will be proportional to concentration of A raised to power of the stoichiometric coefficient A multiplied by the concentration of B raised to the power of the stoichiometric coefficient B. That is the law of mass action for the forward reaction. Then, if we want to introduce a constant, or we want to remove the proportional sign, we will introduce a constant. So if we do so, we can now have that the rate for forward reaction will now be equal to the constant. I will call the constant Kf. The constant Kf multiplied by the concentration of what? A raised to power the coefficient. Then multiplied by concentration of B raised to power of the stoichiometric coefficient, which is B. This Kf now, I will call it the equilibrium constant. Equilibrium constant for the forward reaction, for the forward reaction. That is my Kf. Remember, my Rf is rate for forward reaction. It is equals to the equilibrium constant for the forward reaction multiplied by the concentration of A raised to power the stoichiometric coefficient of A multiplied by the concentration of B, okay, raised to power of the what? Stoichiometric coefficient of B. So this establishes the law of mass action for the forward reaction. Now we can do the same thing for the backward reaction. For the backward reaction, that is to say, if we talk about the backward reaction, the rate for the backward reaction will be proportional to the concentration of the reactant. Remember, for the backward reaction, C and D are now our what? our reactant, and the product is now A and B. So we are now using C and D as the reactant when we talk about the backward reaction. So the rate for backward reaction will be proportional to the concentration of what? C raised to power C, then concentration of D raised to power what? Raised to power D. If we introduce a constant, it will mean that what? That the rate for backward reaction will be equals to Kb into C raised to power C, then D raised to power what? D raised to power the stoichiometric coefficient D. So that means the law of mass action for the backward reaction, the rate of backward is equals to the equilibrium constant for the backward reaction multiplied by the concentration of C raised to power the coefficient C, concentration of D raised to power the coefficient D, because C and D are now the what? The reactants for the backward reaction. So we have established equilibrium constant for the forward reaction, rate for forward reaction, and also rate for backward what? Reaction. Now we can clean the board and we can clean the board and state a condition for equilibrium. Now we know that at equilibrium, that means if equilibrium occurs in that reaction that we are talking of now, at equilibrium, the rate of the forward reaction must be equal to the rate of what? Backward reaction at equilibrium. Rate for forward reaction becomes equal to the rate for the backward reaction. Remember, we have gotten rate for forward reaction as this. We can replace this rate for forward reaction with this, and we can replace the rate of backward reaction with what? This. So that is to say that what? That the rates for forward reaction is Kf into A raised to power A, then B raised to power B, which is equals to the rate for backward reaction. What is the rate for backward reaction? That is what? Kb into C raised to power C, then D raised to power what? D. So Rf is equals to Rb, meaning that Rf is this and Rb is this. Now we want to take ratio, and the ratio we want to take now is the ratio Kf over Kb. That is equilibrium constant of the forward reaction divided by equilibrium constant for the what? Backward reaction. This over this will be equals to concentration of C raised to power C, concentration of D raised to power D, then divided by concentration of A raised to power A, then concentration of B raised to power the coefficient B. Remember, in mathematics, if you say 2x is equals to 4y, if you want to take the ratio of x over y, we are doing x divided by y. What will be at the right hand side? Remember, x over y become 4 over 2. So you go this way and this way. X over y will be equals to 4 over 2. So is of course, x over y is 4 over 2. The same thing we did here. That is Kf over Kb will be equals to this divided by what? By this. That is when you know you have taken the right ratio. Now, this Kf over Kb is the overall equilibrium constant of the reaction. Kf over Kb is the overall equilibrium constant of the reaction. We represent it with capital K. That means capital K, which is the equilibrium constant of the reaction, or the overall equilibrium constant, is actually equals to what? Is actually equals to Kf divided by what? By Kb. Okay? The overall equilibrium constant of the reaction is Kf. That means equilibrium constant for the forward reaction divided by Kb, which is the equilibrium constant for the backward reaction. That means that from what I have told you now, we can replace what? Kf over Kb with what? With capital K. That will mean that what? Our final answer for equilibrium constant of the reaction, which is K, will be equals to concentration of C raised to power C, concentration of D raised to power D, then divided by concentration of A raised to power A, then concentration of B raised to power what? B. You can see with me that this is the equilibrium constant of the reaction. That means anytime they give you to write equilibrium constant of a reaction, it is always product divided by the what? By the reactants. So I've driven the expression for the equilibrium constant of a reaction. Remember where we started? Where we started is actually AA plus BB to give us CC plus DD. And we got that if we are writing the equilibrium constant expression of this reaction, that it will be this. In writing the equilibrium constant expression of this reaction, we got it driven, we have driven it to the what? To be this. Now, that is to say that what? That if I want to write equilibrium constant expression of this, the K, it will be product, which is concentration of C raised to power C, concentration of D raised to power D, over concentration of A, which is the reactant raised to power A, then concentration of B raised to power B. So it's product over reactant. Thank you very much. Please, I will always want you, to subscribe to my video, share the video. Also, you can put your comments in the comment section. Thank you very much.